I welcome you all in a new video tutorial. In this video, we are going to discuss about moment curvature relationship, and we will develop the most important differential equation which will help us to find out deflections and slope in indeterminate beams. For example, a beam is subjected to an arbitrary loading having a significant length. So let's see how can we find out the deflection and the slope at our point of interest. So for that, we are taking a small segment having a length dx from this beam. Before deformation of our segment, it looks like this, where dx represents length of neutral axis and ds is the length of our point of interest or fiber length, and the distance between two is denoted with y. So when the beam is subjected to load, this is how it will deform, and due to this bending, a radius will be formed, and that radius is denoted with rho, and the distance again between these two layers is same y. Now dx, based on the elastic beam theory assumption, neutral axis will remain simple. In order to find the length of ds, so before deformation it is equals to dx, but after deformation, in order to find the dx, we can apply the formula rho times d theta. Since dx is equals to ds, so ds will also be equals to rho d theta. In order to find the ds dash, deformed fiber length, so we can subtract rho minus y multiplied by d theta. And in order to find the strain, that means the change in length per unit length, by putting these two values in this expression, so strain will be equals to minus y over b. And from our basic knowledge of strength of materials, we can know that strain is also equals to stress over modulus of elasticity, and stress is also equals to minus my over I for the compressive region. So by putting strain into this expression, so this expression can be modified in this manner, and by putting the stress value in this equation, so finally the curvature can be represented in terms of m over en. Since we know that dx is equals to rho d theta, by putting the value of rho in this expression will give us d theta is equals to m over ei times dx. And from the knowledge of calculus, this equation 1 over rho actually represents the equation of curvature. By putting 1 over rho equals to m over I in this equation, the expression looks like this, and we know that the slope, and we know that in this expression dv over dx represents the slope, and normally the value of slope is very small, and if you make a square of a very small value, it will be even smaller. So that's why this term is to be taken as 0, and the remaining expression will give you the governing equation for a beam, which will help you to calculate the deflections and slope and indeterminate sections. So this brings to the end of today's tutorial. If you find this tutorial useful, please do like and share, and if you have any doubt, please write in a comment section. For more updates, please subscribe to my channel.